Hello everyone, my name is Gajendra Deshpande and I am working as assistant professor in KLS Gupta Institute of Technology, India. Today I will be delivering a talk on deceptive security using Python. So these are the contents which I am going to discuss. There is introduction to deception, then two deception tools. One is web trap and second one is demon hunter. Then how we have used deception to develop our tool. Then conclusion and finally the references. So to begin with, let me start with a scenario. So imagine you are passing through an unknown street at midnight and you find that some antisocial elements are following you. To save yourself from them, you start running and look for a safe place to hide yourself. On the way, you will find a good person and request him to help you. He hides you in his place to protect you. When these antisocial elements visit a good person's place and inquire about you, a good person misguides them and redirects them to some other place in order to protect you. This is exactly how deception works. In this analogy, you are the resources to be protected. Antisocial elements are the hackers who want to gain access to the resources. And a good person is a deception technique that protects the resources from hackers by making them fall into the trap. So let's try to understand the basic idea behind deception. So deception is a technique where hackers' methods will be used as security mechanism. For example, phishing the fishers. So what fishers do is, let's assume that there is a legitimate website. So fishers recreate the website with the same interface, but the backend will be different. So in the backend, they collect your information to carry out the further attacks. So deception is a military tactic used by both attackers and defenders. Now let's consider the diagram which is there in the slide. So we have two users, benign user and malicious user. Both have the access to the same common user interface. Benign user tries to access the real system with a legitimate username and password, whereas the malicious user tries to gain to the access to the real system but through illegal access. So in this case, if the user is authorized, then system will give him access to the real system. Otherwise, it will redirect the access to the deceptive system. There are two types of deception technology. So one is active deception and second one is passive deception. In active deception, what happens is it will provide the inaccurate information intentionally to the subjects, that is to intruders or hackers, to fall for the trap. In passive deception, incomplete information will be provided to the attacker. So intruders will try to gain the other half part of the information and they fall into the trap. So the deception can also be classified as client-side deception and server-side deception. So client-side deception is a technique generally used by hackers. So it is nothing but phishing. Then if you use the similar technology on server side, then it is called as deception and it is mostly used by security providers. So better deception technology is combine both active deception as well as passive deception. That is provide inaccurate and incomplete information to the hacker. Now, deception evolution and advantages. So deception technology started with the inception of honeypots in 1998. So honeypots are small systems. When the user tries to access to these systems, they fall into the trap in the network. Honey nets are network of honeypots. Then honey tokens are small information, a small piece of information which is embedded in the legitimate information, say database. When somebody steals that information, this honey token will get activated and it will send a notification to the administrator that so and so data has been stolen. So this shows how your data has been stolen. What are the information? So that will be notified to the administrator. So next, honeypot 2.0 was introduced in 2012. So deception technology came into existence since 2016. So advantages of deception are increased accuracy, minimal investment, and it is future ready. So it is even applicable for new technology as well as old technology. So this is a very good deception tool called as WebTrap. So its source code is available on following GitHub resource. So WebTrap is designed to create deceptive web pages to deceive and redirect attackers away from real websites. The deceptive web pages are generated by cloning real websites, specifically their login pages. So it WebTrap consists of two tools. One is the web cloner. It is responsible for cloning the real websites and creating deceptive web pages. And second one is deceptive web server. It is responsible for serving cloned web pages and reporting to the syslog server upon request. To install, you can use pip and install these packages. So it will be installed on your machine. So you need Ubuntu 18 version only. So currently it supports on or works on Ubuntu 18. So this is how you need to use it. So there is a file called the webcloner.py, and you need to supply the argument, that is the path of web page which you want to clone. So once you run it, its local copy will be created on your machine. Then there is one more file called as trapserver.py. So what it does is it whenever somebody tries to access this cloned web page, it will report to the system admin and it will log in the syslog server. The next tool is Demon Hunter. So Demon Hunter tool can be used to create low interaction honeypot servers and their agents, plus the manager software to check the logs. So Demon Hunter allows you to create your own honeypot, all customized by yourself. So from ports to protocol handler. So in this diagram, you can see there is a manager software and there are different honeypots, each configured with a different protocol and with a different port number. So it is possible to configure in a heterogeneous network. Then why we developed our own tool? So we know that cyberspace is a national asset, and nowadays it has become even more important. And XML is the is a heart of many mainstream technologies. So you take any technologies nowadays, XML is the backbone. And with respect to the vulnerabilities are present in the older technologies, and whenever new technology comes, those vulnerabilities are carried out to the new technologies. So we have old challenges as well as now new challenges, because newer technology is built upon the older technology many times. So old challenges also remain. In fact, it becomes even more complicated. So what we have done in our project is to secure web resources from XPath injection attack using modular recurrent neural network. So the proposed solution uses modular recurrent neural network architecture to identify and classify a typical behavior in user input. Once the typical user input is identified, the attacker is redirected to fake resources to protect the critical data. So what we have done is we have implemented a validation technique, which is known as count-based validation technique. So its working is explained in the further slides. Now in this screen, what you are seeing is this small XML code where three fields are there: username, password, and account type. So there is a line which is mentioned in the blue color. So that's the valid XPath query. Whereas the second line, which is displayed in the red color, it displays the malicious query, because you find that valid input are not present there. Instead, some Boolean operators and some numbers are present. That's a malicious attack vector, which is being used to gain the illegal access to the XML file. Now, SEPEC on XPath injection. So this document clearly says that the typely likelihood of exploit is high, whereas attacker skills needed are low. So we had done a literature survey of some papers related to the security and neural networks. And our findings are that neural networks have not been applied to expert injection attacks, especially to classify a typical behavior in user input. And it also showed that how modularity in case of neural networks helps to achieve improved performance. So modular neural networks have not been applied to cybersecurity, particularly to the detection of SQL or XPath injection attacks. So this is the architecture of our project. So it has 3 tiers: presentation tier, business tier, and the data tier. The presentation tier consists of login form, that is the user interface. Then business tier consists of server-side scripts. Data tier stores the data. So in data tier, we have 3 types of data. One is the real XML document, second one is the fake XML document, and third one is the custom error messages. Now, when user enters valid inputs, it's going to serve the real XML document. When user inputs malicious input, it's going to result the data from fake XML document. When user enters invalid input, it's going to return custom error messages. So some examples for each of these cases: valid input, malicious input, and invalid inputs has been mentioned on the left side of this slide. Now, why we need custom error messages? When you enter the input as very large input string or string with special characters, it's going to generate some error messages. So this error message also consists of some technical information. Say, for example, which operating system, which browser, what is the version they are using. So this information can be used to carry out the further attacks. To avoid this, we are going to make use of custom error messages, in which we are going to hide the error message and display the custom error message. So this is the algorithm, and it shows how this works. Now, first step is scan the user input, then determine the length of the user input, then count the frequency of characters, digits, and special characters. So if the frequency of the character is below the threshold, then set the error code to 40. So 40 means valid. So on the right hand side in table 4, that is bottom right corner, the table has been mentioned. So it clearly displays what is the threshold value for each character and a special symbol. And accordingly, error codes are set. So next step, if the frequency of the special characters is above the threshold, then you should set the error code as 4000, that is malicious, else set the error code to 400. Then build the recurrent neural network. So here you need to build 2 recurrent neural networks. One is trained on number of login attempts. The second one is trained on error codes. Note here that here we are training 2 different neural networks. So the recurrent neural network is built using 50 neurons with a hidden layer and LSTM neural network, an output layer as a softmax, and backpropagation trainer is used to train the network on the training data set. Now, why we have created 2 data sets is, if we create a single data set, it will result into large number of combinations of records. So to avoid that, we are training independent neural networks, and whatever result we get, those results will be taken and a separate dataset will be formed, so where the third neural network will be trained, and its results will be used to classify the user input as valid, invalid, or malicious, and based on that the data will be served. Okay, so you can see here in this slide, outputs of both the networks are mentioned, and when the output is when one of the output is malicious, it is classified as malicious. When one of the input is classified as invalid, it is classified as invalid. But when we are comparing the results of neural networks with respect to invalid and malicious, the result is always malicious. To develop this software, we have used PyBrain, that is Python-based reinforcement learning, artificial intelligence, and neural network software. It's a Python-based package. Then for web services, we have used BottlePy microweb framework, And the web server, we have used WSGI reference server of PiterPy and Apache. Then web browsers, to test, we had used Firefox and Conqueror. And for plotting the graph and other things, we have used Python's NumPy and Matplotlib library. So same environment has been used for development and testing. So Pipeline is the modular machine learning library. So to download it, you can go to the following URL and follow the tutorial on the site. And similarly, Bottle is the simple lightweight WSGI microwave framework for Python. So it is distributed as a single file and has no dependencies other than the Python standard library. So it includes built-in routing templates, utilities, and server. So you can again go to the URL and download the software and follow the instructions to use it. Now let's consider the results. So when we consider results, we have true positives, true negatives, false positives, and false negatives. So you can see here we have three fields: number of epochs, modular neural network, and the single neural network. So when we have used modular neural network, always the results are better, except first case. So that's an outlier. And you can also see the consistency with respect to the modular neural network. Then similarly, with respect to false positives, there is the consistency again with respect to modular neural network, whereas there is a lot of variation with respect to single neural network. Then again, comparison of true negative, we have got similar results. Comparison of false negatives, and we have got similar results. Then comparison of response time. So you can see here, as the number of samples increase, the modular neural network starts performing better. So with respect to single neural network and modular neural network, the ratio is 1:1.5. So for a single task, if single neural network is taking 1 second, if single neural network is taking 1.5 seconds, then modular neural network is taking 1 second. Okay. So average detection rate, including and excluding outliers, are mentioned here. So you can observe here, true positive results are always the results are always better when we are using modular neural network. Almost it is double. So when you are used singular neural network, we are getting less results compared to the modular neural network. So similarly, when you consider excluding outlier, the results are better with respect to modular neural network only. Of course, there is a little bit increase in singular neural network also, but modular neural network results are much better. So let's consider the snapshots here. So on the left hand side, we have a XML file which stores the fake data. On the right hand side, we have the real XML file which stores the real data. So this is the user interface. User is going to enter the username and password here. So depending on the type of input, data will be revealed to the attacker. So in this case, you can see here, it is a valid input scenario. User has entered valid username and valid password. It says login successful. Apart from that, it also shows other data. How much time it is taking, what is the neural network output, then what is the browser name, port number, etc. All that we are tracking. Then this is malicious input scenario. Now note here that when user enters malicious input, still it is displaying some output, but this time it is displaying the fake username and passwords. Okay. Plus also note that attacker information is being logged. Then what attacker does is he believes that whatever information he has got, it may be true. So he is going to use the fake username and password and enter the data. So after entering false information, the system says fake login successful. So that means he has been redirected to false resources. He has not been redirected to the real resource. So in this case, what you can do is you also start getting the information regarding the attacker. So you can take now more action or quickly to protect your real data. So the conclusion is that our solution offers improved security over existing methods by misleading the attackers to false resources and custom error pages. So our results also show that the system accepts legitimate input, although the user input may contain some special characters, and rejects only true malicious inputs. So our solution combines modular neural networks and count-based validation approach to filter the malicious input. So our solution has resulted in increased average detection rate of true positives and true negatives, and decreased average detection rate of false positives and false negatives. The security of the systems the security systems have to be successful every time, but attacker has to be successful only once. That is what we can say. So using deception, we may not be able to secure the resources completely, but it gives you additional time to secure your resources and take further action. Thank you.